Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2019 Test 4 Code A and B Physics. Let's move to question number 1. In question number 1, two blocks are arranged as shown in figure. What should be the minimum mass of block B so that the block A of mass capital M will just starts moving? So if I draw the free body diagram, suppose MB is the mass of block B, then MB into G is act in this direction. Let T is the tension in the string, then 2T tension will act in this direction. So at the moment when the mass capital M will just start sliding, these two forces are balanced. So I can say that 2T is equal to MB into G. So at that moment if I draw the free body diagram on block A, then tension T will act in this direction. M into G act in this direction. This is the angle theta. Then the component of tension in this direction is T cos theta, and in this direction is T sin theta. The normal reaction on the block from the ground is N, and let the friction is acting in this direction. So if I write the equation on block A in vertical direction, then I can say that N is equal to capital Mg minus T sin theta. So for the block A to just start moving, T cos theta must be greater than or equal to F max, and the maximum value of friction is mu, that is half into N, that is Mg minus T sin theta, and this is T cos theta. So if I solve this, T is greater than or equal to Mg divided by 2 cos theta plus sin theta. The value of T is equal to Mbg by 2. So if I equate this, Mbg by 2 is greater than or equal to Mg divided by 2 cos theta plus sin theta. So from here we get Mb is greater than or equal to 2m divided by 2 cos theta plus sin theta. So if I observe this denominator, then if the denominator is maximum, then the value of MB is minimum, and the minimum value comes at the equality. So if I take this function as f theta and find out the maximum value of this function, then maximum value of this function occurs when tan theta is equal to half. Suppose if I draw a triangle, if this angle is theta, then this is 1, this is 2, and this is root 5. So from here we get the value of cos theta and sin theta. So the minimum value of B comes at equality, and that is equal to 2m divided by 2 into cos theta, that is 2 by root 5, plus sin theta, that is 1 by root 5. So on solving this, it comes out to be 2m by root 5. So option 3 is the correct answer. So the correct answer for question number 1 is option 3. Let's move to question number 2. In question number 2, a man at point A wants to reach to point B on the opposite bank of the river. The distance BC is equal to B and the width of the river AC is equal to A. The speed of river stream is V0. At what minimum speed relative to water should he swim to reach the point B directly? It means that the velocity of the swimmer with respect to ground is directed along B. So if this is the V net of swimmer with respect to ground, let the velocity of river in this direction is V0. If I draw a perpendicular from this on the V net, and this is the perpendicular, then this U of swimmer with respect to river will be U minimum. And if I say this angle is theta, then this angle is also theta, and I can say that the value of U minimum must be equal to V0 into cos theta, and we can calculate the value of cos theta from this triangle ABC. We know that this is A and this is B, so cos theta is equal to V0 into A divided by under root A square plus B square. So option 2 is the correct answer. So the correct answer for question number 2 is option 2. Let's move to question number 3. In question number 3, a uniform rod of mass 150 gram and length 50 centimeter is connected at one end of the spring of spring constant K is equal to 90 Newton per meter and natural length L is equal to 50 centimeter. If the system is rotated with constant angular speed omega is equal to 10 radian per second, then elongation produced in the spring is. So let the elongation produced in the spring is x. Then if I consider the center of mass at this position, then the distance of the center of mass from the axis of rotation will be L plus x plus L by 2. Suppose due to extension of a string, the force at this point is F, then I can say that F is equal to m into omega square into this separation, that is the position of the center of mass from the axis of rotation. This is my RCM. So the F can be written as K into X, because X is the extension in the spring, that is equal to m into omega square into RCM, that is L plus X plus L by 2. Now I have to substitute the data. The value of K is 90. So 90 into X is equal to m. The value of m is 150 into 10 raised to the power minus 3 into omega square. So the value of omega is 10 and its square is 100 into the value of L is 50 centimeter. So 0.5 plus X plus L by 2, 0.25. So if I solve this equation, the value of X comes out to be 0.15 meter, or I can write it is equal to 15 centimeter. So option 2 is the correct answer. So the correct answer for question number 3 is option 2. Let's move to question number 4. In question number 4, two vertical walls of equal height h are at separation h. A particle is projected from any point on the ground as shown in figure. The minimum possible speed of projection such that the projectile would be able to pass over the two walls is. So the logic behind this problem is that suppose if it is projected with a minimum speed, then when it is projected with a minimum speed at some angle theta let, then the path of this trajectory is something like this. So the velocity at this point is let v and it makes an angle alpha with the horizontal. So in order to have the minimum value of u, our v should be minimum, and our v minimum is such that our projectile just touches the top of the second tower, so that this range is maximum. So I can say that if this range is represented by h, then h is equal to v square sine 2 alpha divided by g. So in order to have v should be minimum, our sine 2 alpha should be maximum, and this occurs when the value of sine 2 alpha is equal to 1. So from there we get the value of v square, and it is equal to h into g. Now if this height is h, this the final speed is v and the initial speed is u, so I can write final speed v square is equal to u square minus 2g into h. So if I calculate the value of u square, it is equal to 2gh plus v square, that is equal to h into g. So from here the value of u minimum comes out to be under root of 3gh. So option 2 is the correct answer. So the correct answer for question number 4 is option 2. Let's move to question number 5. In question number 5, a bead which can freely slide over a string and a block each of mass m are arranged as shown in figure and then released. The acceleration of block at this instant is. So we have to calculate the acceleration of this block at this instant. So in order to understand this, if I draw the free body diagram, mg is acting in this direction, tension T is acting in this direction. So if AB is the acceleration of block, then I can write mg minus T is equal to m into AB. So this is my equation 1. So if T is the tension, then T is acting in this direction as well as in this direction. Suppose at that moment this angle is theta, so I can say that this angle is also theta. So t cos theta will cancel out, and the force acting on the bead in this direction is 2t sin theta. And vertically downward it is mg. Let the acceleration of bead in vertical direction is a into bead. Then I can write 2t sin theta, that is sin 45 degree, minus mg is equal to mass m into acceleration of bead. This is my equation 2. Since we have three variables, acceleration of block, acceleration of bead, and tension T, so we have to write the relation of constraint. In order to understand the equation of constraint, let's analyze the situation. This is the bead, and the angle made by the strings with the ceiling at this instant is 45 degree, or I am saying it is as theta. So suppose if this is bead is moved to this position and the displacement is y, then the situation of the string will be like this. So if I drop a perpendicular from here to here, and this y is very small, so this is my perpendicular. If this angle is theta, then I can say that the perpendicular to this line is this, and the perpendicular to horizontal line is vertical line. So this angle is theta. So I can say that this length and this length, as I have to draw a perpendicular on this string also, if this angle is theta, then this is y sin theta, and this is also y sin theta. So if the block is descended by a distance x, then I can say that x is equal to 2y sin theta at this moment. So if I double differentiate this equation, then I will get the relation in acceleration. So I can say that the acceleration of block is equal to 2 times acceleration of bead into sin theta, or sin 45 degree. So this is my third equation. So if I solve these three equations in order to calculate the acceleration of block, then the acceleration of blocks comes out to be 2 minus root 2 by 3 into g. So option 4 is the correct answer. So the correct answer for question number 5 is option 4. Let's move to question number 6.